people look at technology from the outside and they say that, wow, things move so fast, but when you're in the kitchen, you know that it doesn't always work as fast as it probably could.
Welcome to Beyond the Bench, a very exciting guest for you all today, Henrik Flodell, Alif Semiconductor.
We wanted to make devices that were 100% focused on low power consumption because, for microcontroller guys, that's usually one of the key requirements. For the first time, you can run language models on a microcontroller that doesn't generate any thermals, that fits on a PCB that is super tiny and that you can power, by a couple of AA batteries.
I'm really excited about video language action models, video language models. How far out do you think that technology is?
I don't think it's that far at all. I mean, this is moving really fast. A lot of it is going to come naturally by people observing the quality of the models that are being trained today.
Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Welcome to Beyond the Bench podcast, Hardware Stories That Matter. A very exciting guest for you all today, Henrik Flodell of Alif Semiconductor. Henrik, thank you for coming on the show.
Thank you so much for having me, Bill. I've been looking forward to joining this for a while now.
Me too. Absolutely. So you guys are a younger, I wouldn't say startup, but a younger semiconductor company founded in 2019, right?
Correct.
And you are front and center on low power and AI. So what does that mean to the audience?
So essentially, the reason that Aleph is a thing is because we kind of saw a space in the market that was starting to form where people wanted to combine traditional, microcontroller type processing, those type of workloads with AI elements in order to get essentially better solutions, because you can add, an element of, if I dare call it, statistics to the standard algorithmic processing that people were doing. And there were a whole bunch of ways that could be achieved that nobody was really taking advantage of because it required some, latest generation type silicon architectures to do all the integration of the elements that you need to put these NPUs in place and, other things like that. And the sad truth in this part of the industry, if you're kind of on the inside of it, people look at technology from the outside and they say that, wow, things move so fast. But, when you're in the kitchen and you're, cooking up the food, that it doesn't always work as fast as it probably could. But the building blocks were there. So we thought, hey, we know how to make chips. Why don't we try to just grab all this latest generation technology that isn't being used and start with a clean sheet design, and we can put something together that is, a couple of years ahead of what everybody else is doing right now. And then we can try to capitalize on the interest of running these type of workloads. And, if we can move fast, then we'll stay ahead of the curve, and then we can capture some of this budding market for ourselves. So that's what we did.
And when you guys launched, what were the most common use cases of AI at the time? What did you think? I'm sure that whatever is happening now is not what you expected, but what was that first landscape like?
Yeah. I mean, we're constantly being surprised at what our customers are doing with our devices. It's like they show us things and we go, I did not realize that we could do that. That is fantastic. But I think when we got started, it's actually kind of interesting. Because it's even before we started shipping products to customers. This is kind of back when we were planning everything out and everything was on the drawing board. At the time, people were talking about tiny ML. Essentially, it was like, I have a machine learning model that is small enough that I can convert it to C code, and then I can run that on my Cortex M4. And look, this is so cool because it is something that has been trained to do artificial intelligence and is running on a tiny little controller. But it wasn't real use cases. I mean, it was like, okay, it's of some level of academic interest, but what if I want to do something like actual image classification or actual natural language processing, things like that? Those networks are bigger. There is a lot more compute. It's not really feasible to try to squeeze them down into those super small form factors. I mean, there's some things you can do, but if we kind of look at what we were going for, it was more enabling those. I don't think that I can say standard models, but known AI models that people were training to solve real problems and try to figure out can we run that? Is that something we can provide a path for people to deploy on a truly embedded device that can run on a battery? Because that was kind of the other angle of it for us. We wanted to make devices that were 100% focused on low power consumption. Because, for microcontroller guys, that's usually one of the key requirements. I'm going to make something. It's not going to be plugged into the wall. It needs to last for, a day, a week, a month, depending on, how hard it is to get to that device to replace the battery in it, essentially. So, we wanted to make sure that we did everything that we've done in the past to conserve power, but then also add the ability for this thing to be really compute capable when there is to be done.
And so what does that mean from like the internals, like AI coprocessors, battery management, probably some thermal, like what's the secret sauce under the hood?
I mean, one of the things that we did, and I still believe that we were probably the first kind of MCU mass market company that took this path, was that we decided to integrate NPUs, or neural processing units, next to our MCU cores, so that the MCU core can do the standard application, if you will. It's collecting all the data, it's doing all the real-time tasks that you do with those devices. But then it essentially has access to a co-processor that it can offload the neural network onto, that is much more efficient at actually resolving that neural network, because it can operate from the layers in parallel, right? So you can get a result faster. And in embedded, you usually kind of look at, I want to say power. How can I do that? There's various ways that you can optimize the system for power consumption. But one of the best ways always tends to be just do the work fast. Because if you do the work fast, you can go to sleep sooner. And we figured with an NPU, you can probably achieve a couple of orders of magnitude faster performance to resolve those networks than if you try to run them on these relatively, small cores, if you will, right? If you compare like an MCU and its clock frequency with the kind of things that you run cloud side, it's not the same performance, but you still have the ability to do some pretty cool things in, small packages. And then also for, customers that are designing things to run these neural networks, if it's a wearable, for instance. I think you mentioned thermals briefly. That's something that's really important. If you're going to put something on your body, you don't want that thing to get hot. So it's like, does that require a heat sink? Well, then no, it doesn't go in the wrist strap or in the earbuds or, whatever that might be. So.
And what are the like, are you focused, what are the industries that you're seeing the most traction? It sounds like wearables is a huge focus. Yeah, tell me a little bit more about where you guys are getting adoption.
We see adoption across quite a few different types of applications, verticals, whatever you want to call it. Essentially, any kind of system that is processing data that is collected from different sources, different types of sensors, etc., can potentially benefit from an added element of edge compute using neural networks inside them. I like to kind of think about it as, if you're doing a sensor-based solution and you've been doing algorithmic sensor fusion, as long as you can get that algorithm to actually be, super accurate for what you're looking for, then it's probably fine to do that without any kind of AI. But that's not always the case. Sometimes it's like, I get a bunch of data and I'm looking for roughly this. And the neural network can be really efficient at very quickly figuring out if you're in, that range where you want to signal, hey, the interesting thing is happening now. So, I mean, what that translates to in terms of real use cases, wearables is one thing, because, anything that is collecting, body type parameters tend to use a quite broad mix of sensors. So both on the consumer side and on the health side, there is definitely interest for these type of solutions. We also see a ton of applications in the industrial space where people are, monitoring things that are moving on conveyor belt. It might be just looking at gauges remotely and trying to figure out, well, these 3 gauges, if they're all doing, this type of motion, then that means that the state of the system is something that I have to involve myself in, because it's not supposed to behave like that.
Is it not hilarious that we are doing visual inspection of analog devices for
I, you know, I want to say absolutely, but when you think about it, if you kind of take a couple of steps back and you look at the amount of analog sensors that are there that work perfectly fine, it kind of makes sense that you just go, well, I don't really want to replace them just because, Well, I can put this
No,
one
no.
thing in front of it and then have that take care of it for me instead of me just sitting there staring at it all day.
Yeah, this gauge has been here for 30 years and it works great. Let's not try to put some electronics in there. Let's
Exactly.
figure out another way. Yeah.
Exactly.
I was watching an interview with Mark Zuckerberg this morning on the Meta glasses, and I was thinking of you because he was talking a lot about the wristband and the capabilities of that band. And right now they have like gesture controls and whatever, like you do things with your hands. And he was saying that the as you continue to wear the glasses and as the model continues to get better, it's going to become just like super fine grained movement, and like people won't even be able to really tell that you're wearing or that you're controlling the glasses with your hands. And like that is a perfect use case for a leaf. So I don't know if you're a Meta, but you should go knock on the door. It seems like they're
It's
definitely thinking in a similar direction.
yeah. I mean, and use cases like that, I think are so cool because it is you can clearly tell that it's something where it's a new control surface for devices that is being developed, and it's going to get better and better with use because the more it's going to be used by people, the more data gets collected, and the more they can tune those models to be pitch perfect essentially, so that it becomes just as seamless as when you pick up your mouse and do whatever you do with your PC every day, and you don't even think about the fact that this is a wireless piece of equipment with a very very capable laser inside it that is helping me figure out where I spelt that word wrong in my spreadsheet.
Yeah, and it's completely commoditized, which is wild. What are some like customer examples that really surprised you? You mentioned that you guys are being surprised every day. Does anything come to mind? Anything that you can share?
Um, it's always a challenge because we don't want to say things that had not been announced. But I mean, just in terms of recent surprises, there was a use case by a customer of ours that was using our device to do some pretty clever, essentially audio segmentation. So that you could or kind of lock in what you were hearing coming from one specific source, and it mixed up all these sounds, and it was able to very clearly pick out exactly the stream, from all of these jumbled up sounds that was of interest. And it's like, I understand exactly why this is a good thing. I have no idea how you're doing it, but I'm so happy that we were able to help you.
And what does the like software tool chain around this look like? Like are people like cloud training these, quantizing existing models? Like what is the actual like development experience of getting ready to port to the Leaf architecture? Like what are people most commonly using?
We've tried to the best of our ability to set up what we call enablement around our devices in such a way that what you're being productive with today, you can continue using. Now, I mean, there's obviously some supplier proprietary tools out there that is not going to, try to support something we make. But a major part of our strategy is to kind of target using IP inside the silicon that has broad ecosystem support. So that's one of the reasons why we've partnered very closely with ARM on a lot of things, including the NPU, because this is also one of those things where since this technology is evolving so quickly, right? We were approached by a lot of different entities when we were doing our spec about, hey, we can help you design your own, or you can use this thing that we made, etc., etc. And some of those things are very interesting, but at the end of the day, for developers, the silicon needs to be capable. The tools also need to be very easy to use and very capable so that they can be productive fast. So we figure that if we use IP that is licensable, that makes that IP more attractive for a larger number of software vendors, and that means more
Yeah.
choice for our customers, right? And then there will be more frameworks supported. There will be more ways to optimize models. There will be more data sets available to train them on, and uh, that's just benefits everyone. So that's kind of the strategy that we've taken overall. Standard development for our devices, you can use almost any tool that supports ARM-based technology. We use a lot of open source tools in-house. A lot of commercial, big name ARM tools support us. When it comes to the AI side, there are a couple of different paths, I want to say, depending on where the model that you're working with comes from. If it was something that was developed in a TensorFlow framework or a PyTorch framework or ONNX framework, things like that. The NPU itself requires the model to use integer data types for activations and weights. And Then there are, depending on kind of if that is a TensorFlow formatted model or a PyTorch formatted model, there's different ways to perform that quantization. But then there is basically a conversion step to turn it into a binary that can execute on the NPU. And like I said, inside the application, the system treats that NPU kind of like a coprocessor. You call a function that says, hey, go and run an inference on this data with, this binary model representation that is stored in memory somewhere. And then you get interrupted by.
And are you so you've talked a lot about ARM and about low power. You guys bleed between microcontroller and microprocessor, it feels like, right? Like it seems like what you're doing is very, very unique for a super low power setting. Can you like talk a little bit about that and a future question on next products that you've recently announced? But yeah, where do you live on the like bare metal RTOS versus going towards Linux?
No, but it's an excellent question, and it was a thing that we spent a lot of time analyzing, because what we wanted to make sure that Alif was not was what we call a point product company. Like, I have one solution for one specific problem, and if your solution deviates, even a slight bit from how we imagine that you would use it, it's not a good fit. We wanted to have a pretty broad performance continuum that we could operate within. So we created a flexible architecture that allows us to essentially remove blocks and add blocks, kind of like Lego bricks to it. So we can have, a single core MCU device, a dual core MCU device, a device that combines microcontroller cores, microprocessor cores. I can have one MPU, two MPUs, three MPUs. It's very easy for us to kind of scale that on a performance continuum. And then in addition, make sure that all of those performance points are software compatible, and to the extent that we can make them also hardware compatible. So we have a lot of devices in our lineup that, as long as you're sticking within the same package type, they will be pin-to-pin compatible. So if you're making, a little thing and a big thing, you can just put an Alif footprint on one PCB and then decide when you manufacture, do I want this thing to be able to do, the big workload, or is the small one fine for this?
That's really interesting and does not feel typical of how most silicon companies work. It's typically like, here's my thing, hope you can make it, hope this maps to your architecture. But it sounds like you're working very closely with your customers and the use cases. So like are you coming up with one generation and listening for feedback and then expand that? Or are you actually helping build like purpose-built footprints directly for the customers?
For right now, what we've been doing is we went out pretty broadly. We came out the gate back in 2000. When did we start ship? We started shipping in 2021. We started shipping, in volume to customers. We had 4 series of devices out the gate that we started shipping at the same time. And then later we added a wireless product family that we called Balletto. And then even more recently, we introduced 3 new series to our flagship Ensemble family. And we had kind of planned that evolution from the start. We needed to start somewhere. So we started with what at the time was the latest generation MPU from ARM, the Ethos U55. And we wanted to have, a broad spectrum of devices that supported that. But then we wanted to slot in at various points on that scale also the ability to accelerate what's called transformer operators. These are a special type of operators in some of the more modern machine learning models. And it's what makes, things like language models possible. There's a lot of modern vision-based models and audio-based models that also use transformers. But that was something that we kind of wanted to then evolve into. So what we're doing at the moment is not so much, here's one family of devices and here's the next one that is designed in a completely different way. We had always planned it out to be almost, as seamless as we can possibly make it, to move between these performance points and just, add features and make, adjustments where it makes sense to do so based on how we see that the devices are being used.
And on that last point, how the devices are being used, where are you getting the most like pull? Like everybody's not everybody. Clearly, there's a lot of market in the low power, but everybody's like very focused on the humanoid, the like super heavy, high end GPU. Are you seeing like natural pull into these higher power, high use case scenarios, or are you getting even further and further deep onto the low power spectrum?
I mean, what we're seeing, and this is actually kind of interesting, we're almost seeing the opposite. It's not so much that people are pulling, well, for some use cases, it depends on what you're going to do. Some use cases really require a lot of processing capabilities. But there's been kind of an arms race when you just look at the devices that are going straight for performance on being able to say that I have the most tops of anything that is out there. And then you look at what the people want, people that are designing systems, what do they want to use them for? And they go, why do I have to have all this capability? I don't need that. I need less. If you can make it so that the system itself is easier to design, that I require fewer external components, that I don't need to worry so much about my thermals, that I can control cost by doing chip down instead of having to get, a complicated module type design, then I'll be happier. So those are the kind of, let's say, situations where we can really provide a lot of benefits for users. They're designing with something today that is essentially overpowered and likely also a lot more expensive. It has to be. And what they're really looking for is, I want a microcontroller that can do some of these things, and I want it to behave like an MCU. I don't want it to behave like something new and strange that I've never used before. So
That makes sense. Talk to me about like regional adoption. I guess before we do that, where are you guys manufacturing? That's always interesting.
So we're fabless because factories cost a lot of money. So, we're a young company. We'll have to see how things turn out if we end up with our own at some point. But we are manufacturing through foundry partners, and the majority of our silicon is being built in either Germany or we also have the ability actually to build some devices locally in the US. So that's very nice.
Okay. Awesome. And where are you so there's great engineers in Germany, solid choice. Deep experience in the space. Where are you seeing the adoption? Where are your dominant markets?
I mean, we're really seeing adoption across the globe. It follows the same patterns, if you will, as traditional microcontroller solutions. At least that's what we've seen over time. We did see initially the highest level of interest in the US, but that's, I kind of attribute that to the fact that a lot of the companies that are doing these next generation type products are based here, at least the design teams are. But as that kind of percolates out through, manufacturers and, other types of organizations that are working with these companies, then they start working on their own designs based on the technology as well. So, we see good traction across North America, Asia, Europe, across the board, essentially at this point.
Very, very cool. One thing that always fascinates me, and you're a marketer by title. Have you always been a marketer? I mean, you are, and marketers in silicon are unbelievably technical. But like, what's your background?
I started my career in this industry as a firmware programmer for medical devices way, way, way back in the early 90s. Little data recorders that provided the ability for patients to not be inpatients, but you wear the recorder and then you go home and then you come back a couple of days later and upload all the data, and then that gets automatically analyzed and we figure out what's wrong with you. So that's my background. So I started kind of on the software side of things, and then I slowly graduated over to the hardware side. So that's why I always have, I try to always be mindful of the fact that you can make the best hardware solution ever, but unless you have some really good software to run on that, nobody's going to be able to be productive with it.
Yeah, it's just unfortunately a paperweight without any firmware on it, so you can only do so much. And so you started on the firmware side. Did you go through like any traditional like electrical engineering, computer engineering, or has it just been like deep, like you just went from firmware deep into electronics and then came out the other side and like product and marketing?
I started doing firmware development for this medical device company that I worked for at the time. I got acquired by Medtronic, and at the time that it got acquired, they moved the headquarters to a different country. And then I decided that I should probably go get myself a computer science degree because this is fun. So that's what I did.
Nice. And was that where was that?
That was in Sweden, in Stockholm. That was back in, I think it was in the early 90s that that company got acquired. So it's called Synectics Medical.
Yeah, one of the things, and I'm a software background. That's why it's intellectually curious to me. I came from like general software, a little bit of HPC, scientific computing, and now I'm in this hardware space. And I'm just totally unsurprised that you're saying our main markets are worldwide. The silicon industry is so global. It's unbelievable. And yeah, I mean, I was on a call just this afternoon with people in London, talked to somebody in India, and I, London, Indian, Ireland. I think I've talked to more people outside of the US than in the US today. So it's
No, but it's also, when somebody has a good idea for, a device that hasn't really been a thing before. And somebody shows that, like you were talking about the Meta glasses, for instance. So those type of AR glasses, I mean, there's so many of those that are now being built by different companies. And I mean, I'm really excited about, it's a cool form factor, but what really excites me is what are they going to be able to do? Because I've seen so many examples of like, oh, this one does an overlay so that you can see, connects to your phone and it will plot the route that you're taking to get from A to B. And this one you can play games on, and this one will, recognize every face that you meet. And it's, that kind of stuff I think is really awesome because you only need to get a couple of those killer apps and that's going to be just a must have for everyone, right?
Yeah, and he was talking about the wristband and the fine grain motor control, really
Mhm.
amazing. And then they have a speaker in the nose piece, and he says it's so calibrated to where you could be in a wind tunnel and it comes across clear as day. And that is all AI.
Right?
I mean, there's no
Exactly.
hardware that does that on its own.
Mhm.
It's all AI enabled hardware. What do you what do you see like kind of next generation on like I'm really excited about video language action models, video language models, like really like robust vision systems on the edge. How far out do you think that technology is from being like generally applicable?
I don't think it's that far at all. I mean, this is moving really fast. And it's also, I think a lot of it is going to come naturally by people observing the quality of the models that are being trained today. Because, you can make statements like that. You can go up on a stage and you can say that, I have this, super fidelity through my AI for the microphones. And then when people see that, well, they actually do, they're able to achieve that. How do they do that? And how can I make something that is even better or that can do, something else that they are not doing at the moment? And then that just starts to snowball, right? So it's the ketchup effect. I think that we're kind of at the point now where that the plug is about to come out, and this is really going to start to spread into all kinds of areas in the market where you may not even have imagined that AI had a play in the past.
Yeah, we had a conversation recently with the Intel RealSense group and all of the AI enablement they're putting directly into the cameras. And it's not even just like the head unit that's doing the intelligence, all the peripherals, the sensors, and they're providing like really high quality streams back to that machine that's using it as an input. And it's mind blowing. I think we are like at the brink of a golden age of hardware, and I'm on X or Twitter, whatever you want to call it, but it's my feed is just like fully robotics, fully hardware, and it's just like mind blowing everything that's happening on a daily basis.
It's interesting to me also kind of how this the pendulum swings between where you want all this stuff to happen, because way back in you know computing history, everything was mainframes and you had little terminals that connected to it, and then all of a
Yes.
sudden it moved from the mainframe to your desktop, and now I'm working on PCs, and then it was the cloud, and it was like, no, you shouldn't store anything on your desktop that you have on your in front of you. Push all the data up to the cloud and we'll do the processing there. And now it's coming back again, but it's going into even smaller devices. So
Yeah, the pendulum swings 100%.
yeah.
Well, tell me about this, your next generation architecture. I know the buzz that I'm excited about is the E8, and a couple of the other series around that. What are you guys doing next? What's this launch about?
So what we have done with what I like to call the even numbered ensemble devices, we introduced three new series recently: the E4, the E6, and the E8. And the distinction between them is essentially how many CPU cores that are available to you. But what we did in all of those series is that in addition to the NPUs that we have used in the odd numbered ensemble series, we've added the latest generation Ethos U85 from ARM that enables you to accelerate transformer-based networks. So essentially, for the first time, you can run language models on a microcontroller that doesn't generate any thermals, that fits on a PCB that is super tiny, and that you can power, by a couple of AA batteries. So it adds a new class of possibilities, if I can say that, and not sound, too aloof or whatever. But it's going to be very interesting to see what people will be able to create armed with that kind of potential.
And what are the language models you're actually seeing in practice being quantitized and ported to these chips? Like what generation is it? Like all straight from Hugging Face, and they then whittle it down from there, or what? Who are the leading models that are going low power?
We see a large interest in deploying models that have been developed from the PyTorch framework on these type of devices. And with Meta creating Executorch, that is going to be a lot more straightforward than it used to be. So we're excited about that. Just in general, in terms of what the models do, true. What we are seeing people very curious about, and there's a lot of R&D efforts going into this, it has to do with, the additional context essentially you can get from a transformer networks versus, something like a CNN or an RNN type configuration. If you think about like an AI agent that has some level of awareness of, what you said previously in a conversation and can go back to that is something that, will become available for developers to implement. So it doesn't just become, every time you wake up your voice assistant, you have to start a relationship with that assistant over from square one. I'm hoping that we'll end up in a situation where they will actually get better at understanding you and what it is that you want them to do over time. And we're also seeing some pretty, I don't know, some people might be afraid of this, but I think it's kind of interesting to see where it will go. People want to use this to create better interaction from toys, essentially, so that, you can have element of interaction and understanding beyond just, pull the string and it will say the thing and flail the arms around a little bit. So yeah, there's
Yeah, I have a 5-year-old daughter, and I think a lot about like when do we get our first robotics kit? What is going to be the? 'Cause I was telling her last week, and maybe I've already said this on a pod. So Kristen, please forgive me, but we were driving to school, and I was like, your daddy works in software, and she was like, boring, and I was like, well, what do you think of robots? And she was like, well, are robots even real? And I'm like, oh yeah, they're real. And I showed her some videos, and I was like, well, what do you think's running the robot? And she was like, huh? And I was like, software. And then she was like, well, that's boring. And I'm like, come on, Cora. But anyway, I think that like the physical AI, the toys, the robots, that really like brings it home and is really engaging. And with these new tools and technologies and, the chip capabilities, the software ecosystem, I'm excited about a world where it's much more accessible and approachable to, kids and even folks like ourselves that are excited to play with it and don't need the deep expertise to make it happen. I think we are right there right now. It's really exciting. Well, Henry, let's close there. This was awesome. I'm so glad you came on the show, and I think we should have you back in 4-6 months, check on how things are going. I know you guys have a heavy conference season and a lot of product rollouts, but we're really grateful for your time. And if anybody's looking for more information, how should they find you?
The easiest way to find me is to go to our website, alifsemi.com, hit the contact us button, and let us know what it is you're working on. We'll get in touch with you, and we'll be happy to help.
Awesome. Well, with that, we'll call it. Thanks so much, and have a great day.
Thank you so much, Bill.
See you later.
All right, everybody, just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.